Swayam Prabha. Digital India. Educated India.
If you understand perspective, raise your hands. Okay. If you think you understand perspective, raise your hands. Okay. So maybe I'll try to devote some time to revise whatever we have covered in the last 2 or 3 lectures, and I'll also talk about a new method that I got introduced to by Professor N. Kishore yesterday evening. I'll talk about that. So quite a few of you guys came to me yesterday and said, sir, I mean maybe it'll do us a lot good if we can have an extra session. And I was like, fine. So after the class yesterday, I went to the lecture hall office, spoke with Mr. Verma about the availability of any of the halls. He said L16, 11 o'clock. I said, great, fine. So, and then I sat thinking, man, I mean, I'm not prepared for today. What am I going to be doing? So maybe I'll just revise whatever we have covered. And then I met Professor Kishore in front of director's office, nah? And then he explained a method which seemed very logical to me, and then I'm going to talk about that today. So this scene, let me animate the scene. So stay with me here, okay? Let's say that face of the cube in top view is this table, okay? Let's say the face in top view over there is this table, okay? This is the position of the viewer. That's me. So if you're looking from the top, you would be looking at somebody's head, okay? And imagine that I, as a viewer, am standing here, and you're looking at me as well as this table from the top. And let's say that this table is at an angle. I'm here, this table is there. You guys are looking at me as well as the table from the top. So you see my head, which is that point, the position of the viewer, that is me viewing the table in the top view. Okay? All right? Now the picture plane. How about the picture plane? The picture plane is going to be a vertical plane that would be in between the object as well as myself. Fine? Fine? All right, good. So this is me, the viewer, object, and the picture plane is in between me and the object. The picture plane is vertical. In the top view, that would appear as a line, which is here. Fine? All right. Now, my eye would be looking at different aspects or different features of the object. The vertex on the left, left top, right bottom, right top, and the vertices below. Okay? And those would be represented by the rays going from this point here up till all these 4 vertices. Okay? So much so for the top view. So you get the sight information. You get the sight information from the top view. Okay? Now forget about the top view for now. Let's go to the front view. So of course you are looking at the profile view or the side view of the object. This is not the true side view. Okay? This is the side view that is enough to give you the height information of the object. Fine? This is where the ground line is. Okay, so this is where the object is stationed. All right. Horizon line. So imagine that if I'm standing on the ground Okay, this height corresponds to the distance between my feet and my eye level. Okay, this is where my eye is going to be. Okay, and so happens that in perspective views we don't need this information, so we let go of this information. All we need from the front view is the ground line and the horizon line. Okay, this is where my eye is, and we can get the true height information from the profile view of the object. Okay, now it doesn't really matter where the ground line is. If you push the ground line below, okay, the object gets pushed below by the same amount, and the horizon line gets pushed below by the same amount. It doesn't really matter where you position this. What is important is how you're positioning your horizon line. So this is again the line that differentiates between the sky and the ground, okay, your eye level. So what matters is how you're positioning your horizon line with respect to the ground line. That is what is important. Okay, now the important thing for you to do is to combine the top view and the front view. Okay, like so. The picture plane, the top view of the object, and the viewer position, a point, we call it the station point. These are parts of the top view. Okay, with me? Okay, and the ground line and the horizon line, they are the part of the front view. Okay, you're going to be getting the slight information by projecting the rays from this point to different vertices of the object, and you're getting the height information by projecting horizontal lines, lines which are parallel to the horizon line from this object. Okay, now I've already covered this example, so I'll quickly go through this. So if you're looking at a point far away at infinity along a line parallel to this, you'll be getting this point as the vanishing point. Now imagine, just in case in the isometric drawings that we have drawn, what? Yeah, the projection lines are too light. Is it? Let's worry about that. Let's worry about that in a while. Let's see how it goes. So if you're looking at, may I? Okay. So if you're looking at an object along this direction far away, you'll get the image over here on the picture point, project it down, you get the vanishing point. So just imagine that you're drawing something very similar to an isometric view. So you can imagine that this thing is the direction along the x-axis, this thing is the direction along the y-axis, and the height is coming out of the screen. Okay, so with that, this would be the vanishing point for all the edges that are parallel to the y-axis, and likewise this would be the vanishing point for all the lines which are parallel to the x-axis. Okay, can't see those construction lines, na? Okay, all right. Let's see how it goes. Okay, so you know that this edge is on the picture plane, it will be in true length, project it down, get the true length of this edge, right? The corresponding x lines, they vanish, let me be here, the corresponding x lines, they vanish at VPX, the corresponding y lines, they vanish at VPY. We can't see the construction lines, can we? Yeah, okay. Give me a moment. You have seen this example before, so you know where the lines are going to be. Don't worry about that. It's going to be a hard time to get this thing fixed. Okay. Anyhow, so you see that this vertical edge corresponding to this, it would be lying at, in between these two rays, vanishing towards VPY. Okay. This edge would lie in between the two rays, vanishing towards VPX. Okay, and then draw two more vanishing lines, complete the block. Okay, this is something that we have seen before, not a problem. Something that you understand, hopefully. Okay, right? So keep this in mind. This is where I'm going to be introducing you to what I say Professor Kishore's method. Okay, I'm going to be making a few changes, and I want you guys to be attentive over here. I'm going to be making a few changes. Change number 1, I'll not draw the perspective with pre-specified vanishing points or pre-found vanishing points. I'll not be using vanishing points at all. Instead, what I'll do is I'll use the true profile view. Okay. Okay. So the top view remains the same. From there, I use projections like we do in orthographic projections. I name these vertices as AE. So A is on the top, E is at the bottom. Those as BF, B on the top, F at the bottom, CG, not the center of gravity, but CG, C on top, G on bottom, and DH. Okay, D on top and F on bottom. Once again, number 1, I'll not use vanishing points. Number 2, I'll use the true profile view of the object. Okay, and I'll see if I can make a perspective, a nice perspective. Of course, that's the picture plane there. Now, if you're looking at the picture plane and the object in the front view, your picture plane will be passing through the edge AE. All right. If you're looking at the picture plane in the profile view, how would your picture plane be looking like? It'll be a line, and be a line that passes through. So it'll be a vertical line. Okay, that passes through AE. That picture plane is not visible here, but let's try. Okay, it's visible now. Now, the second thing that you would want to keep in mind. Look at this point here. What is this point? Station point. In English, it is the position of the viewer with respect to the picture plane in the top view. Okay, so you would know this distance from here towards the picture plane. You will know this distance. How would this distance show in the profile view? In the profile view, if you use the same distance from here to here, rotate it, okay, come over here and plot the position of the eye on the horizon. Okay, would it be this point? Okay, once again, this is the position of the viewer in the top view. Okay, so this is where the viewer is positioned with respect to the picture plane. This is what the distance is from here till here. Okay, the same scenario, if you want to capture in the profile view, how would you want to do that? I'm here. From the top, you see my head, you see my station point, the head position with respect to the picture plane. Okay, what you guys see now is the profile view. This is my line of horizon. Okay, this is where I am standing, of course, and that is where the picture plane is. Okay, What is this distance from here to the picture plane? Is that distance the same as this distance? Yeah? Yeah? Alright. So if you know this point, if you know the position of the picture plane in the top view, you know the distance, use the same distance to locate the station point or the position of the eye of the viewer in the profile view. So this is where the eye of the viewer will be in the profile view. This distance is the same as this distance from here till here. Okay, and of course the eye is going to be lying on where? The horizon line. Right? Now comes the interesting part and a very logical, very reasonable part. And follow me carefully. Position of the eye of the viewer in the profile view. Alright? Let me use the short forms. SPT, station point in the top view, SPP, station point in the profile view. Now what I am doing is I am looking at vertex A and vertex E from here. This is very dim, I am sorry about that, but just imagine that I am looking from here at vertex A and vertex E. Man, it's going to be difficult for me to explain. Let me see if I see those lines. This helps. Okay, so picture plane. This is the picture plane here. I'm looking at vertex A and vertex E from the station point in the profile view. Okay, it so happens that AE lies in the picture plane. Okay, so I use horizontal projections directly. Okay, and then I look at the vertex AE from the station point in the top view. So it lies in the picture plane over here. I take those projections, and what I have over here is a vertical edge AE in perspective. Okay, straightforward. Here comes the interesting part. If I look at BF from the station point in the profile view, right? Now this ray is going to be cutting the picture plane at this point. Okay, so this means that the image of point B will be here on the picture plane in the profile view. Okay, likewise the image of point F will be here on the picture plane in the profile view. B prime, F prime. I project these guys horizontally. Okay, and then I use the site information from the top view. What do I do? I'll tell you what. So follow me, and I'll make certain revisions to the slides and then post it on the web for you guys. So just imagine that I'm looking at B from here. If I look at B from here, it will be crossing the picture plane here somewhere. Okay, I take the horizontal projection down just in case that you have been doing in case of your conventional 2-point projections. And then I look at F. Okay, same thing. So this ray would be cutting the picture plane here somewhere. I project it down, and this is what my BF is going to be. It's going to be vertical again. Okay, so this is the new thing. This is the new thing. This is the same thing that we have covered in the previous lectures. Okay, so D prime, H prime, they will be lying at the same 2 points as B prime and H prime, nah? On these 2 rays. Okay, take the horizontal projections, same thing. From the station point here, look at DH over there. Okay, that would be cutting the picture plane somewhere over here. Project it downwards, and then you'll be seeing DH. Okay, the same thing with CG. You're looking at C from the station point, SPP. This would be the image of C in the picture plane, on the picture plane. This would be the image of G on the picture plane in the profile view. Okay. Project them horizontally. Now look at CG from this position. Use the ray. That ray is going to be intersecting the picture plane somewhere. Project that intersection downwards. Let that ray cut these 2 points or these 2 lines, and essentially you will be getting this edge CG. Okay. You have all the 8 vertices that you need in your perspective figure. That's it. Yeah. You know what the interesting part is? You know what the interesting part is? You don't. If I extend the edges along the x and y directions, oh, I can see those projection lines now. If I extend these, I will be getting the same vanishing points that I have been using. So this is the perspective using the new method. This is the perspective using the old method. New method, old method. Exactly at the same locations. Okay. Now you had a lot of questions with regard to how to choose the vanishing points over here, etc., etc. This actually sounded a lot more reasonable and logical to me. So I would recommend this method to be used for even single point perspective and 3-point perspective that hopefully I'm going to be covering today. With me? Nah. Are you with me? Yes. Good. Clear? I'm really sorry about the projection lines. I thought they would be visible, but anyhow. Difference in the 2 methods. In the new method that I had introduced to you today, I did not use the vanishing points. Rather, I chose to use the true profile view of the object. Okay. In the previous method that we had covered, we had used the vanishing point information, but we had not used the true profile view of the object. So that's the difference. Okay. So a hexagonal block, prismatic block using the new method. Again, I have a feeling that projection lines will not be visible. Let's try. So top view is a hexagon. AG, BH, CI, DJ, EK and FL are edges going into the screen. A, B, C, D, E, F are vertices on the top face. G, H, I, J, K, L are vertices on the bottom face. AG, FL, BH, EK, CI, DJ. Okay. Your station point in the top view, SPT, remains the same with respect to the picture plane here. Okay. It's so frustrating for me. I mean, I can imagine. So imagine that you have a picture plane over here. Okay, let's see if it's better. All right, so station point SPP, you are looking at edge AG. Okay, so it's going to be, so these 2 rays are going to be intersecting with the picture point or with the picture plane here at these 2 points. Take the horizontal projections. Okay, you would actually know that face AGFL will be in true shape because the face is on the picture plane top view. So get that face directly, no problem. AGLF, all right. Now, so yesterday I made a mess by showing too many construction lines, so I try to avoid showing additional construction lines. Okay, so I start with new construction lines. So I'm looking at edges BH and EK. Okay, BH and EK. Okay, where will these two rays intersect? I'll get the images of E and B here and H and K here. Okay, take the horizontal lines. Now I look at the edge BH from the station point in the top view. Okay, that would intersect the picture plane over here. I make the projection downward. Essentially it's a vertical line, I believe, just about close to vertical line. Okay, so this is my edge BH. Right. I look at EK. I get the intersection here, project the intersection downward, get the intersection between these two rays and that vertical projection here, okay, and create an edge EK. Okay, now I look at edges CI and DJ, the images of which are going to be formed on these points and these points. Take the horizontal projection. Okay, from the station point in the top view, I look at CI, get the intersection between this ray and the picture plane over here, take that intersection downward, allow this vertical projection to intersect with this and this horizontal ray, okay, and create the new edge CI. Likewise, I look at DJ from SPT, same thing, same thing, same thing. I have got 6 vertices at the top and 6 vertices at the bottom without using vanishing points. I can join these vertices and get a hexagonal prismatic solid without the use of vanishing points. It's pretty nice, very logical, very reasonable method. Do you want to see where the vanishing points are? They have to lie on the horizon line. Stay with me. Stay with me. They have to lie on the horizon line, and it so happens that they do. You get the right vanishing point here and the left vanishing point over here. Okay, now if you draw a ray that passes through SPT and this vanishing point, that would be parallel to what? AB. And if you draw a ray which is passing through SPT and this vanishing point, that would be parallel to What? Come again?
This would not be parallel to it.
Which one?
SPD and that vanishing.
Why?
So because when we take the vanishing point, we make a line parallel to AB and let it intersect picture plane at a point and project it down. Yes. To the horizon.
Fine. Here we did not use the vanishing point. But what we are doing is we are saying how these guys are going to be vanishing. What we are doing is just the reverse. We drew this perspective with the true profile view, the true top view. Stay with me. True profile view, true top view, got this perspective, and then we are trying to figure where the vanishing points are. How do we figure the vanishing points? By looking at a pair of parallel edges vanishing at a certain point. Okay, so what I draw is a ray passing through this, a ray passing through this. Okay, these three guys apparently are what? Concurrent? They are intersecting the same point. Okay, and likewise, this horizon line and the ray which is along this edge and the ray which is along this edge, they are also intersecting at the same point. Okay? Yeah? Now, using the same method, I am going to try to construct a 3-point perspective. Okay? You can try constructing a single point perspective using this method. Simple examples. Okay? I am going to be using the example of a cube to construct a 3-point perspective using the same method. Okay? So what you see is the third angle orthographic projection, the front view, the top view, and the profile view. Okay, so the top view, in the top view, the cube is rotated by a certain amount, let's say 45 degrees. Okay. Now, how would I get a 3-point perspective? Rule number N in perspective, all lines have to be running away from the picture plane. None of the lines should be parallel to the picture plane. Only then I can get a 3-point perspective, otherwise not. Right? Right? So what do I need to do for that? I need to make another rotation. So it so happens that you would be getting a 2-point perspective in this, because you still have an edge, or rather you still have 4 edges, 1, 2, 3 and 4 parallel to the picture plane, which is here. So I need to make one more rotation. Okay? What would I do is I would rotate the cube in the profile view and get the respective views in the top and the front view, like this. Use projections. Go back, rotate this cube in the profile view by a certain amount. Okay, when I rotate this, what happened to this? This gets rotated about this axis. Okay, and this also gets modified accordingly. Okay? You have done orthographic views, so it shouldn't be very difficult for you. Now, I am going to be using this picture and this picture to draw a 3-point perspective. Okay? The top view and the true profile view. Right? Okay. These vertices 1, 2, 3 and 4, they correspond to these 4 vertices over here. Right? Where are these vertices in the top view? These guys or those guys? Careful. Careful, careful. You know, I was making this animation at 8 o'clock in the morning. Huh? The set of vertices below or the set of vertices above? Look at the projections. These 4 vertices are getting projected over here. These 4 vertices are getting projected and coming back here. Look at the projections. So these 4 vertices, they'll appear at the bottom or at the top in the top view? At the bottom. So that is one thing that you need to keep in mind, which is where I struggled for half an hour, almost 45 minutes this morning. So A, B, C, D is the bottom face, E, F, G, H is the top face in the top view, A, B, C, D is this face here, E, F, G, H is this face here in the profile view. Clear? Look at the position of the picture plane in the top view. It is passing through the vertex E this time. In this example, the picture plane is passing through the vertex E. Okay? Correspondingly, in the profile view, the picture plane is going to be a vertical line that passes through this vertex C. Okay. I choose a station point in the top view, SPT. This can be any point. Okay. And the same rule, whatever this distance is, okay, I am going to be using the same distance from this picture plane in the profile view and have my eye on the station point in the profile view on the horizon line. Fine? Here, SPP. And then the drill remains exactly the same. Exactly the same, no changes. Okay? Look at these vertices from the station point in the profile view, draw horizontal projections. Look at the corresponding vertices in the top view from the station point SPT. Okay? Draw corresponding vertical projections, find the intersections, find the vertices, and that's it. Let's get started. Looking at AE, I'm looking at A and I'm extending this ray because the image of A is being formed over here on this picture plane. Okay? Take that horizontal. I look at AE. Now I need to extend this ray because the image would actually form on the picture plane over here. Okay? Draw the verticals, find the intersections, and get the vertices. Okay? The same thing for all edges, all vertex pairs. Look at BF, extend this SPP B ray to intersect with the picture plane, draw horizontal from here, draw horizontal from here. F gets formed here, the image of that. Look at the corresponding vertices in the top view, get intersections between the ray and between the rays in the picture plane, draw the verticals, let them intersect with the corresponding horizontals, get the vertices. Again, same thing. This is for DH. And this is for the center of gravity. Four edges of a block of a cube. Okay, I don't know what perspective it is. I join these vertices and get a perspective. Weird looking thing. Yeah. Fine. I still need to convince you that this is a 3-point perspective. Option 1, would your block look like that? Or would your block look like this? It would look like this. Yeah? Or this? Have you heard of something called a Necker's cube illusion? Have you heard of something called a Necker's cube illusion? Yes or no? No? Yes? All right. For those who have not, all right, look at this vertex E and look at this vertex C and tell me which one is in front of the other. Huh? Yeah. So if you're looking at this object, At one time, it will appear to you that vertex E is in front. At the other time, it will appear to you that vertex C is in front. Careful, careful. So, that is what the Necker's cube illusion is. Yeah, that's what the illusion is. Anyhow, so if this is the true perspective of this cube, let's try to figure out where the vanishing points are. Draw lines parallel. This is my first vanishing point. Sorry, got it wrong. Yeah. This is not the correct. What? I got this wrong, all right. I got this wrong. Let's see. Let's see where I made a mistake. I have 3 vanishing points, all right, but 2 of them, they happen to lie on the picture plane, not the horizon line, which is strange. It's all right. Can you help me figure where I have made a mistake? Can you help me figure where I have made this mistake, where I have made a mistake? The entire thing? All right, fine. Think about it. Yeah? Picture plane would be more towards the left side. No, but my picture plane, I decided my picture plane to pass through E. I decided my picture plane to pass through E. Well, this distance I thought was the same as this distance. No idea? Where did I go wrong? The orientation. The other alternative.
The other alternative turning the blunt edges. The Necker's cube illusion, you know that there were 2 possibilities.
No, this has nothing to do with the Necker's cube illusion. Where did I go wrong? Yeah? Are the distances between SPT and the corresponding picture plane? Okay, all right, okay. Are these distances equal? Yeah, looks like they are. Where did I go wrong? You know, the only problem with this is that I'm getting the vanishing points on the picture plane and not the horizon line. Yeah? So this is what I'll do. Yeah?
In the diagram below, A, B, E and F are in the same plane. And in the top view,
A, B, C, D are on the same plane. Are on the same plane.
just look at it.
A, B, C, D. A, B, A, B, E, F. Alright, so A, B, E, F. Okay. So I got A, B, E, F. Yeah. I got that plane. I'll tell you what. I'll post these slides on the web. You can take a look, and if you have found my mistake, share with me in the next class.